Hello Calculus fans, this is a video about, for Calculus 2 that has to do with sections 5.3, 5.4, and 5.5, which is the fundamental theorem of calculus, net change, total change in the substitution rule. There's a lot of stuff that happens in that section, but what I'm trying this term is to give you some test preps, which is a small sampling of some old exam questions relating to these topics. And what I hope to do in these videos is kind of talk through these. So you can, if you pull this up in Panopto, you could sort of go directly to whatever one you have questions about. But let me say a few things, and as I go through, I'll try to pull up some old exams. So this is from the winter 2015 exam. It says a particle is traveling up and down along a straight line. Its velocity, find the total distance. So this to me is an important named thing that we spent quite a bit of time talking about in lecture in section 5.4. So if you need to review this, that's what we did there. But this should be automatic. You should be writing the integral from 0 to 2 of the absolute value of 4t cubed minus 4t. And we have a very clear procedure. This was about the whole idea of what an integral is and what it isn't. But there is no, this was the Dr. Love's goals for a run. There's no way to know how far I ran without knowing when my velocity changed from positive to negative. So step 1 is finding when this equals 0. So now it is time to factor. And when I look at that, there are actually 3 solutions. T could be 0, that's one solution. Or t squared minus 1 can be 0, which is t squared equals 1, which gives 2 solutions, t equals minus 1, t equals 1. Okay, we were trying to figure out what happened. So if you were to sort of give a timeline, the question's asking what happened between time 0 and time 2. So this solution is actually right at an endpoint, so I'd have nothing to split up. But there is one of these that's in between, which is 1. So I need to figure out what's happening from 0 to 1 and from 1 to 2, and I need to integrate those separately. So step 2 is to split it up. If you're actually going to graph this, it's positive and negative, but I talked about in class how you don't even have to be able to see that. You just need to know when it changes. So you need to compute this, and completely separately you need to compute this, and that's what I talked about in class. And so this is going to be t to the 4th minus 2t squared from 0 to 1. So it's going to be 1 minus 2 minus 0. So this is negative 1. And what that means is the object went left, left, 1. Or, sorry, the problem said up and down, so I better use the same language. So we would say down 1. So if you actually could see what was going on, here would be whatever time 0, you'd have this object, this ball, and it went down 1 foot. Okay, then what happened? So then, from 1 to 2, and this entire time this was negative. That's why we solved first to figure out when it changes. So then it changed. It's going to be t to the 4th minus 2t squared from 1 to 2. So it's going to be 2 to the 4th minus 2 times 2 squared minus 1 minus 2. So it's going to be 16 minus 8 plus 1, because it's negative, negative 1. So 17, so I think that's 9. And so that means it's going to go up 9. Let's label that. So it's going to go up 9 feet. This is not to scale. I should have made it go much further. Way up here. The question, if the question was asking for a displacement, you would say 8. It's 8 feet from where it started, but that's not what it asked. It asked for the total distance you ran. So the last step of the process is to interpret. And the total distance would be, well, it ran 1 foot plus 9 feet, so it ran a total of 10 feet. So we did that in class. That's an important concept. That's very likely to be on your test somewhere. So let's take a look. Winter 2015, make sure I didn't make any silly mistakes. As I look through, it's just good for us to get our eyes on exams. There's an integration, there's a substitution. There's a substitution, there's a substitution. There's a fundamental theorem of calculus part 1. Net change, total change. Okay, it's 10. Good. But now you have to say, could I do that on a test? And really, this is a formulaic one. This is a named concept. And so that one, you don't want to spend time on the test. You should just be going. Okay, so anyways, you sort of, as you're doing this sort of test prep, you go, okay, do I know for certain I could do that? That's part of what you're learning in college is, have I prepared? Do I know, am I sure I know it? And that's kind of personal to everybody. Okay, so here's another one. It gives you this crazy looking thing where there are variables up here, and that immediately makes me think fundamental theorem of calculus part 1. The fundamental theorem of calculus of part 1 tells you how to take the derivative of such things. So don't get distracted by the rest, but it says we are trying to get this area. We're painting this. One person is painting this side. One person is painting this side. That's the story I always say. And as you're painting, more of the wall is getting covered. So the question is saying, at what rate is the wall being covered at 2? So there is a little bit of translating. The question's asking for this. But really what you need to do is find the derivative. And that's what we should, even if the question looked weird to us, that's what we should immediately be wanting to do here. Okay, so we need to find a prime of t. And I talked in class about the shortest way to do this. And the shortest way to do this is, what is that, a 1/6. Oh, there should be a 6 here, but a 1/6. That's the function. I'm going to write the function again. And there's not anything really to do or hardly even show here. It's just, do you remember the fundamental theorem of calculus part 1, which said, take this, put it, if you're taking the derivative of an integral, it simplifies. You have to substitute this in here and then multiply by the derivative of that, which is 1/3. And we talked about y and what this means. And then you have to do minus, you put this one in, negative 2t, then multiply times the derivative of the inside, which is negative 2. And that's it. If I were to simplify this, well, I don't even need to simplify it. The question doesn't say simplify. The question says plug in 2. So now let's finish the problem. We'll plug in 2. A prime of 2, so it's negative, so it's e to the negative 1/6, 2/3 squared times 1/3 minus e to the negative 1/6. And I'm putting in a 2, so it's going to be 4 squared. Negative 4 squared, but it's just going to be 16 times negative 2. So I don't know if that simplifies nicely. This is going to be e to the negative. One of these 2's will cancel. So 2/27 times 1/3. Yeah. And then this is going to be plus 2 e to the negative 16/6, which is 8/3. Ooh, I thought the numbers came out nice. So I'm going to go peek at my solution. Plus 2. I intentionally don't look at the solution until after we've done this. So I want to experience like you're experiencing it. I wonder if I have a number off. Let me look here. So this is spring 2013. Spring 2013. So we have a simplification integral, substitution, substitution, substitution. Oh, I asked for it as a decimal. That's why. Well, maybe I didn't ask for it as decimal. It's a pretty messy number. Square feet per minute. That would be the rate because it's area. That's it. But really you had to immediately say, oh, this is all that it's asking for is the derivative. So that's a question that looks worse than it is. Okay, we have a theory question. This is winter 2018. Let's see what happens. Here we go. So they tell us that the integral from 0 to 4 is 10. The integral from 3 to 4 is 2. And the value at 3 is 13. What is the value at 0? So several things. It's a little bit of a puzzle, but the main tools you would have here is the following. So one is just writing down the fundamental theorem of calculus. This thing is the exact same as f of 4 minus f of 0. And they told you that was 10. This one is the exact same as f of 4 minus f of 3. And they told you that was 2. And they told you that this right here was 13. Can you find a way to solve this? So that in itself will do it. You could also think in terms of area, but let's just think about this. So if I know that f of 4 minus f of 0 is 10, and I know that f of 4 minus 13 is 2, can you figure out what this is? So you can see I haven't really thought about my approach yet. I just was writing down exactly what they told me. So this means that f of 4 has to be 15. And so I have 15 minus f of 0 is 10. So f of 0 has to be 5. Done. That was winter 2018. Let's take a peek. Winter 2018. Substitution. Okay, here's a total change question, absolute value. Notice how you set it equal to 0, it would set it up. Here's a fundamental theorem of calculus part 1. And there's that problem we just did. Okay, then we've turned it into substitution. Now, I may make just a separate video about this, but substitution is just something we need to practice a lot. You need to pick the inside. You need the derivative to be the outside the derivative. This is negative 2 sine of 2x dx. And this is just something you're going to need to practice. You're going to have to do this several times on the test. It's a big part of exam 1. So practice. But this becomes, when you plug in a 0, you get a 1. When you plug in a pi over 6, you get cosine of 2 times pi over 6. This is why I would put the unit circle on my note sheet. So that's the x-coordinate on the unit circle at 60 degrees, which has to be a half. So anyways, this is a half. This is u to the 4th. This is sine of 2x. This is 1 over negative 2 sine of 2x. Those cancel, and we're off to the races. Now, a few things. If you don't like having the reason I have a 1/2 there is because that, when I plug that in, that's what I got. If you want to flip these, you can. In fact, it's kind of nice because it would change the sign. That is not necessary. What is necessary is then integrating and evaluating. So this becomes u to the negative 3, 1 over negative 3, 1/2, value from 1/2 to 1. This is going to be negative 1/6, 1 over 1 to the 3rd, minus 1 over 1/2 to the 3rd, which is negative 1/6, 1 minus 8, which is 7/6. Let's see how I did. This is winter 2018. And I really just randomly grabbed some problems. Okay, 7/6. This one, I actually did this one in class. I don't know if it's worth me doing it again. But if you do u is x squared plus 5, you get du is 2x dx. You get dx is 1 over 2x du. And you replace this. And we talked about this in class. It's the last example we did in this lecture, but these don't completely cancel, so it appears something went wrong. But I talked about how if that ever happens, there's an easy fix. Well, not easy, but there's a fix. You go up here and you solve for x squared. So x squared is u minus 5. So you get 1/2 the integral of u minus 5, u to the 1/2. And now we're going to simplify and integrate. So this becomes u to the 3/2 minus 5u to the 1/2 du. And that's going to be 1/5 u to the 5/2 2/5 minus u to the 3/2 times 2/3 plus c. And then our final answer, we'd replace u. So if I was doing this, I would simplify it. I would say 2 over 25, distributing the 1/5. I'd have x squared plus 5 to the 5/2 minus those 5's cancel, and so you just get 2/3 x squared plus 5 to the 3/2 plus c. Done. So let's take a look at that one. Yes, it's a little fuzzy. 1/5 and we should clean that up. 2/3. So there you go. Oh, I forgot there's a few more. I was thinking I was done. Tomato problems. So this one tells you the acceleration is negative 32. So that means the velocity is negative 32t plus a constant, and the height is negative 16t squared plus ct plus d. Now we got to read the information. It is thrown downward, so it has some initial velocity. It tells you at 3 seconds after being thrown, the height is 240. And at that moment, so at that same time, the velocity is negative 110, downward 110. That's the information we need to put in. The easier one to deal with is the velocity, so let's deal with that first. The velocity at 3 is negative 110, so that implies negative 110 equals negative 32 times 3 plus c. And from that we can solve for c, which is negative 110 plus 96, so that's going to be negative 14. Now that we know what c is, we can plug in the rest. So they told me the height is 240 at 3. So when I plug in 3 squared plus c, but c is negative 14, times 3 plus d is 240. And now we're going to solve for d. I think rather than spending time to do that, let's just pull it up. Winter 2018. Tomato problem. There's that negative 14. There I plugged it in, calculated 426 feet. And d is the initial height. That answers the question. Maybe I'll leave this honors question for you and come ask me in office hours if you like. You can find the solutions for this on there. There's just 2 parts to it, which make it a little more involved. And that's a little more challenging than I would ask in a non-honors course. But it's kind of fun. You're trying to hit me with a water balloon. Hope that helps. If you click through old exams, you can practice a lot more of this. And in my previous video and this one, I've now looked at a large part of old exams. You can now attempt all these substitution problems. There you go. Fundamental Theorem of Calculus Part 1, total distance, midpoint rule, tomato problem. The only thing we haven't done yet is this question, areas and volumes. And that's there'll be a separate, that's the discussion of chapter 6. So you're now pretty much ready for anything, or you can study, except the areas and volumes. All right, hope that helps.